Now we're going to be talking about a little bit complicated adding and subtraction problems. How's this a little bit complicated? The first couple of guys that we talked about had only one or two sets of parentheses. This guy has three sets of parentheses. The rules are still the same. Okay? So the first thing that we know is that to remove these parentheses, we're going to have to distribute the coefficient, not power rule, because again, three terms, trinomial, trinomial, trinomial. Cannot do power rule. It's a little confusing because remember, when we saw parentheses, we told you how to get rid of them by power rule. But if that only works if you have one term in the parentheses. Have more than one term, got to distribute that outside coefficient. If you don't see an outside coefficient, remember, slip in a 1, slip in a 1, slip in a 1. So distribute. 1 times 12 q to the third. 1 times negative 3q squared, negative 3q squared. 1 times 5, it's going to be a positive 5. Now here, remember, we're distributing not only the number, but its sign. So distribute this negative 1 out. Negative 1 times 4q cubed will be negative 4q cubed. Negative 1 times this will be negative 5q squared. Negative 1 times positive 2q would be a negative 2q. Now be careful here. The negative 1, okay? Maybe I should have made the negative over here. So you're going to distribute a negative 1 out. Not only the number, but its sign that was in front. So then we get negative 2q cubed. Then positive 4q. And then a negative 10. I'll just put it at the end. Okay. So you notice when you have a negative sign, you just change all the signs. Negative, negative, negative. Just to the opposite. And then here, opposite, negative. Opposite of this, positive. Opposite of this, negative. So you can see, when you distribute a negative 1, it changes the signs. Now that we got rid of the parentheses, then we have to collect any like terms. Be careful. So sometimes we might start off by looking at the highest exponent. Some people call it degree. So notice that this cubed can go with this q cubed, which can go with this q cubed. So we have three like terms. That shouldn't bother you. When you have three like terms, just work 2 at a time. So this is a positive, this is a negative. So this and this will give us 8q to the third. Why 8? Different, subtract. Who wins the tug of war? Team positive. Now that I have 8 and a negative 2, positive 8, negative 2, subtract. So we're going to have positive 6q cubed. See? 3, 3, 3, stays 3. So all I did was just take each of these guys and just do them separately. This and this, we told you gave you 8 cubed, and this, that's how I got 6. Okay. Now let's do our squares. We know that this, and no, that's it. So we only have these two. So again, negative, negative. So 2 negatives, I'm actually going to add, and we're going to get a negative 8. Why negative 8? 5 versus 3, 5 wins, team negative. Q squared, notice it stayed q squared. After the squares, look for single q's. That's a constant, doesn't have a q. That's a single q. That's a single q. That's a constant. So we can combine the single q's. This is a negative, this is a positive. So here I have to subtract. Who wins the tug of war? 2 players or 4? Team 4 does. So we're going to get a positive when I subtract 2, Q, Q, stays Q. And then how about the constants? Hey, we got two constants. This is a positive, this is a negative. So then when you subtract, because they're different signs, who wins the tug of war? 10 players beat out 5, so you're going to get negative 5. So our final answer is going to be this guy. Even though it had 9 separate terms, our answer only has 4 terms because we were able to collect a lot of the like terms. This is in the correct format because it goes from 3 to 2 to 1 to 0. Constant term last. Let's do another one of a trick guy. Now these were written what we call horizontal. Sometimes they might write a problem vertically. What do I mean by that? They might say subtract. They usually give you a direction. So instead of them writing it vertically, or sorry, horizontally, they stack them on top of each other. Now I know some people don't like it when it's stacked. I'm one of those people who don't like it when it's stacked either, because notice it has the direction subtract. Subtract means that you're going to take this top polynomial and subtract it with this bottom exponent. But a lot of people forget that when it's subtract, you have to change all these signs. But if I rewrite it like this, parentheses here to separate the top from the bottom, this polynomial from this polynomial, and subtract means I want to put a subtraction sign between the two polynomials. So when I write it like this, then it looks like just like all the other problems that we're dealing with. So if you've ever seen it stacked vertically, use parentheses to separate each of the terms. If it says add, put an addition sign between the two polynomials. Or if it says subtract, put a minus sign between the two polynomials. Once it looks like this, then you go like, oh yeah, that just looks like the problems that we've been working with. Slip in your ones. So when you distribute, you're going to get a positive 5a squared minus 7ab plus 8b squared. Remember, because distributing by a positive 1 doesn't change anything. But when you distribute a negative 1, you're going to get a negative 3a squared. You're going to get a positive 2ab. Remember, negative times negative is positive. And then negative times negative is a positive 2b squared. A lot of people see subtract and forget that you have to change this. See how it's now negative? Change this to make a positive, and change this to make a positive. So it's easier just to put parentheses, and if it says subtract, put a minus sign here. And then rewrite it as one big horizontal line instead of stacked. Once we get here, you should know your rules. We got rid of the parentheses, then we know the next step is to collect any like terms. Remember, a squared goes with a squared, or ab, or b squared. Now how do I put this in order? Again, because we have two letters, a's and b's, start with a. What's the highest exponent for a? Looks like square. So let's combine these first. This is a positive, this is a negative. Different signs, subtract, we get 2a squared. Remember, a squared stays the same variable part, a squared. Now a to the first part, no exponents. So this is a negative, this is a positive. 7 abs plus 2 abs, keep the same label, abs, AB. Just know that the coefficient, -7 plus 2, different signs, subtract. This time, team negative wins. 7 players versus 2. This has more players, so it's going to be a -5 AB. And now that we're done with the A's, we have to do the B's. This is already on the board, so I don't have to pay attention to this. I have to look at my highest exponents, B squares. Because remember, these are gone, because they went together. These are gone, they went together, so it's just only these two. This is a positive, this is a positive. So when we have two positives, even though the problem said subtract, technically I'm going to add. 8 plus 2 is 10. B squared, remember, stays the same variable part, b squared. Make sure that you put a plus sign to show that it's positive. This is in descending order, and notice that no term is like, so this is considered our simplified answer.